Have you ever seen something in a science lab that looked like straight-up magic? Well, today we're diving into a chemical mystery that looks just like that. We're asking, how is it possible for two totally clear liquids to mix together and, poof, create a solid right before your eyes? It's not magic, but it's pretty darn close, and we're going to solve this puzzle together.
So yeah, that's the big question for today's explainer. How in the world does this happen? What even is that solid stuff? And why does it show up sometimes but not others? To figure this out, we're going to have to put on our detective hats and follow the clues, step by step, just like a scientist would.
All right, first things first, let's get our terms straight. That mystery solid that appears out of nowhere, it has a name. It's called a precipitate. And here's the key. It wasn't just hiding in the liquid. It's a brand new substance that forms when the chemicals react. You can kind of think of it like they're all swapping dance partners, and this new pair creates something solid. Now, every good investigation starts with a theory, right? A hunch. In science, we call that our hypothesis. So before we start mixing anything, we need to make an educated guess about which chemicals we think are actually going to react. This is going to be our starting point.
And here they are, our lineup of chemical suspects. We've got 6 different solutions. All of them are a type of chloride. Our mission is to predict which of these guys, when mixed with some sodium carbonate, is going to form that solid precipitate. Now, this is a tough call without a chemistry degree, I get it. But making a guess is the whole first step. Go ahead, pick a few you think are going to be guilty of reacting.
Okay, got your predictions locked in? Good, because now it's time to move from guessing to doing. We're heading into the investigation phase. Theories are great, but the only way to really know what happens is to run the experiment and get some cold, hard evidence. The procedure itself is actually pretty simple. We're going to take our 6 suspect solutions and put a few drops of each into its own test tube. Then we'll add the sodium carbonate to every single one. And finally, this is the most important part, we just watch. We observe carefully and collect our first set of clues.
And you got to keep your eyes peeled because the result isn't always super obvious. A precipitate isn't always a big, chunky solid. Sometimes it can be really faint and wispy, almost like a ghost in the tube. Other times it looks kind of like jelly. You might even have to be patient for a minute to see anything happen at all. A good scientist, just like a good detective, needs a keen eye for these little details.
Now, any strong investigation needs more than one piece of evidence. So we're going to run the whole test again, but with a twist. We're changing a key variable. This time, instead of sodium carbonate, we're going to add sodium sulfate. This is going to test our suspects in a whole new way and give us a much clearer picture of what's going on.
All right, the experiments are done. The observations are all recorded. This is it, the moment of truth. It's time to put our initial hypothesis, our educated guess, right up against the cold, hard facts from our investigation.
This is the question at the heart of literally every experiment. Did our predictions hold up? Were our hunches right? Or did reality have a little surprise waiting for us? Let's find out. And here we go, the reveal. In the carbonate test, barium chloride, calcium chloride, and strontium chloride all formed that solid precipitate. The other 3? Absolutely nothing. So why? Well, it's that partner swap. Barium, calcium, and strontium formed new partnerships with the carbonate that are insoluble in water, a fancy way of saying they can't stay dissolved, so they crash out of the solution as a solid. The other chemicals made new partnerships that are soluble, so they just keep floating around, totally invisible to us.
Now for the sulfate test. And this is so cool because it shows how changing just one ingredient changes everything. This time, only barium and strontium chloride formed a really thick solid, and calcium chloride, which was a strong reactor before, now it only makes a faint, wispy little cloud. Turns out, the sulfate molecule is just a little pickier about its partners than the carbonate was. This is the whole basis for what chemists call solubility rules, the guidelines that predict which chemical pairs will create a solid.
So this is the question we have to ask ourselves now. It forces us to look at the difference between what we thought would happen and what actually went down. And now that we kind of get the why behind it, all about the solubility of these new chemical pairs, answering this question is where the real learning starts. And that really brings us to our final verdict here. The whole point of the scientific method isn't just about being right the first time. It's a process. You see something happen, and then you dig in to understand the rules that made it happen. Through careful experimentation like this, a simple guess gets transformed into a verifiable, explainable fact. So I'll leave you with this final thought. In science, when your prediction and reality don't match up, is it a failure? Absolutely not. It's a discovery. It's a new puzzle that you get to solve. Those moments of surprise, those "whoa, I did not see that coming" moments, that's what drives science forward. That's what leads to a much deeper understanding of our amazing world. Thanks for joining the investigation.